Good evening, students. Today I am going to present a 3 by 3 matrix, and let us see how we can find its inverse using the method of row operation. In our previous class, we saw the row operation could be applied to a 2 by 2 matrix. A similar procedure let us apply. I have kept the matrix ready for you. The first step goes like this. The matrix A, you know the step. We are going to transform the matrix from this equation A equal identity matrix times A to the other equation, to the format 2, I equal to A inverse times A. Let us see how we go about it. In the case of 3 by 3, identity matrix, which means 1 0 0 0 1 0, third row 0 0 1. And now, as we learned yesterday, I request students to concentrate, focus on column 1. On column 1, you find two non-diagonal elements, which are 5 and 0, 0. And fortunately, one element is already a 0. So, the element 5, which is in position second row, first column, A21, I am creating a rough column for you. So, in column 1, we concentrate. The element second row first column has to be converted to 0. So this is our aim. And when you are trying to convert A21 to 0, which means 5 has to be converted to 0, and to convert to 0 you need another element to compare. As I told you, students can imagine solving simultaneous linear equation in x and y. I told you what you would do in case of eliminating x term. So same thing here. Imagine you are having 2x and 5x here, and I would like to eliminate the 5 from this row. Why am I choosing 2? You have to always choose the element present in the diagonal. So here the element present in the diagonal is 2. Okay. So compare the 5 with 2, and as we did yesterday, obtain LCM. So you understand the LCM is 10. So how do I get 10? Choose the multiplier. For 2 the multiplier is 5, and for 5 multiplier is 2. And where you are going to apply the correction or the transformation is taking place in row 2, because my intention is to convert 5 to 0. So it is the row 2 which is undergoing transformation. So R2 transforms to what? So the element 5 is present in R2, and that requires multiplied by 2 so that it becomes 10, and 2 is present in row 1, which requires the multiplier 5, and by doing that you get positive 10 and positive 10 here. And how do I convert it to 0? By subtraction. So please understand, this is how you present the row operation equation. Okay, and row 2 is transformed, and what kind of operation you are doing it, mention it here. Perform the operation for the row present in LHS and RHS. See how it is performed. In order to avoid the error, let us do as error-free operation. How do you do it? Twice R2, write it up put it up in rough column, 5 R1. So what happens when you multiply row 2 with 2? Do for all the elements, it is 10 multiplied by 2, 1 into 2, 0 into 2, 0 into 2, 1 into 2. again 0 times 2. 5 times of row 1, that gives 10, 0, minus 1 into 5, 1 into 5, 0 and 0. And what I am trying to do, subtract. So I am following up with a change of sign everywhere and put up the result in row 2. So the result is, after subtraction, it is 0, 2, positive 5, negative 5, 2 and 0. And since we are not performing any operation in row 1 and row 3, you can simply copy the elements present in row 1 and 3. So 2, 0, minus 1 on the RHS 1, 0, 0. Row 3 I am simply copying the elements LHS, RHS 0, 0, 1, and we are going to fill the row 2 with the result obtained here. And what is that? 0, 2, 5, negative 5, 2 and 0. Fine. So that is what is the result obtained. And at the end of this operation, students have to keep a watch. Have you completed column 1? Yes, we have completed column 1 because the given question had a 0 already in third row first column. 5 was a non-zero element which we have now converted. So our operation on column 1 is completed. Now we have to shift our focus to column 2. Now in column 2, what is the non-zero element? Non-zero and non-diagonal. Okay. Diagonal element is 2. Don't bother about it. It is a element which we will require as part of the identity matrix. Non-diagonal element which is, non-zero is the one present here in third row second column. So third row second column, A3, 2 has to be converted to 0. And how do we achieve it? We achieve it by comparing with the diagonal element present in column 2. So what is the diagonal element present in column 2? It is 2. So we require LCM of 2 and 1, which is very simple, 2. And you can choose the multiplier. So row 2 to be multiplied by 1, row 1 to be multiplied by 2. So to make the elements equal, 1 multiplied by 2, 2 multiplied by 1. And whatever operation you intend to do, perform on this element is performed on the whole row. Alright. So what is the transformation we are going to write? What row we are actually operating on? Third row, because 3, 2 is converted to 0. So your operation is on row 3, and row 3 has the 1 and the multiplier is 2. So you need to write the transformation equation like this: 2 times of row 3 and 1 into row 2. So 1 into row 2, let me write row 2 only, and the LCM is positive 2. So you get positive 2, positive 2. In order to get 0, I need subtraction, and you are storing the result in R3. So R3 is transformed into 2 times of R3 minus of R2. Let us write what is 2 times of R3. Why are we doing it? To make the whole thing error free. Okay. We can do it in your mind, you can do it in your head and write it, but definitely it may involve some error, okay, because of some kind of panic or anxiety while working out in the examination hall. So 2 times R3, continue. So 2 times 0, 2 times 1, 2 times of 3, 2 times of 0, 2 times 0, 2 times 1. So 0, 2, 6, 0, 0, 2. So make sure you have completed 6 elements. And R2, you are not multiplying by any other number other than 1. So simply copy R2. It is 0, 2, 5, negative 5, 2 and 0. And once again, what is the operation you are performing? Subtraction. So let me mark change of sign here and obtain the result 0, 0. 6 minus 5 gives 1, 0 plus 5 gives positive 5, 0 minus 2 and 2 minus 2. Okay, so that is the result, and that result goes in R3. And what it implies? It already implies we are not performing any other operation. We are not performing any other operation in row 1 and 2. So copy the elements. Let us copy the elements in row 1. Row 2 has elements 0, 2, 5, negative 5, 2 and 0. And the last row, row 3 is filled with the answer obtained from the calculations. Is that done now? So you can follow, the students can observe. Now column 2 operations are over because diagonal element is alive, non-zero. The other 2 elements have been converted to zeros, and that is considered success. Now the final stage of success, you have to move on to, let me create a rough column for the next sequence of operation. Your focus is on column 3. Your focus on column 3. On column 3 you find there is a diagonal element. So what are the diagonal elements? Shall I highlight? 2, 2, 1 are diagonal elements. Non-diagonal elements in column 3, minus 1 and 5. So now students may be wondering, sir, we have 2 non-zero, non-diagonal elements which are to be converted to 0. Well, you approach one by one. I need to convert this element minus 1 present here to 0. And how do I do it? I will have to compare this with the diagonal element present in column 3, which is position 3, 3, by comparing minus 1 and 1. So neglecting sign, LCM is 1 only, and by simply adding element 1 and minus 1, everyone knows the answer is 0. So I need to convert in column 3 the element first row, third column, second row, third column. 2 elements must become 0. Our first operation, concentration will be on A13. So minus 1 has to be converted to 0, as I told you, compare with 1. So row 1 and row 3 is simply added. Row 1 elements, row 3 elements are simply added. And where is the result stored? In row 1, because our operation is on row 1. So row 1 we have to perform the operation as row 1 plus row 3, so that this element becomes a 0. Okay, focus on that one only. Minus 1 plus 1, it is giving you 0. Don't bother in the meantime about other elements, because they would not be disturbed in this operation. Okay, when I say not disturbed, okay, the 0 would remain as 0. Okay, so that is the idea. So R1 elements, let me write. What are the R1 elements? 2, 0, minus 1, positive 1, 0, 0. And row 3, 0, 0, 1. On the RHS I have 5 minus 2 and 2. And what is the operation we are doing? It is a addition operation. 2, 0, 0, 6, 0 plus, negative 2, 0 plus 2. Okay, and where we are storing the result? In R1. Okay, I will write the matrix a little later. Hold on. We will complete this also. What is that? This 5 is to be converted to 0. by comparing with the diagonal element 1 only, which means the position, the second row, third column position, A 2, 3, I want to convert to 0. And how do I do it? By comparing with the diagonal element. So it is a LCM between 5 and 1. So I get LCM 5. So which means I need to choose suitable multiplier. So 5 needs to be multiplied by 1. 1 needs to be multiplied by 5 in order to arrive at the common LCM element 5. So when I say multiplied 1, I can simply write the row 2. When I say multiplied by 5, row 3 is multiplied by 5, so it is 5 or 3. Okay, so what is the operation you should perform? It is 1 into row 2, 5 times row 3. Okay, and whether we are adding or subtracting, the sign is same. By multiplying, I get 5 also here. So I can subtract to get 0, 5 minus 5. And the result is stored in R2. Is that okay? Students, now this is your first time learning. This is the first time learning. When I say first time learning, this is for the first time you are presenting two operations in same step. That is the what you call the procedure and shortest method in order to arrive at inverse operation. In our method of obtaining inverse operation, you will be what you call very happy to note step 1, step 2. As soon as you complete the step 3, you have the inverse with you. So this is our method. Okay. So in the third step, I am asking you to complete both operations, otherwise you will be wasting one more step. Okay. Whereas this can be combined in the same step. So one operation does not affect the other operation. So let us do it. The LCM of row 2, let us write it, and 5 times R3, and let us keep the result, calculated results ready, and then go for writing up the matrix. R2 is 0, 2, 5 from LHS, minus 5 to 0 from RHS. 5 times row 3, 0, 0, 5. 5 times of the right hand side, 5 times 5, 5 times minus 2, minus 10, 5 times of 2, positive 10. Is that understandable? And the operation you are performing is subtraction. So let me go for the change of sign. Write the result. So 0 minus 0, 2 minus 0, 5 minus 5, minus 5 minus 25. So that gives negative 30. Okay. 2 plus 10, 12, and 0 minus 10, negative 10. So this is what the result, and the result is going to be in R2. Let's get ready. Put the results together in the matrix. LHS matrix, RHS matrix multiplied by A, don't forget. We have operated on row 1 also, row 2 also, but not row 3. So row 3 element I can simply copy. The answer is 0, 0, 1, 5 minus 2 and 2, which is same from the previous step. We are copying. And row 1 plus row 3, the result is here. So let's copy that result. It gives 2, 0, 0, 6, negative 2, positive 2. And the result for row 2 is kept ready here. It is 0, 2, 0, minus 30, positive 12, minus 10. Minus 10. So that is the matrix obtained. So I told you After 3 steps, what you have with you is a presentable matrix. Of course, the LHS is still not, it is a diagonal matrix, but still yet to become identity, because the number is 2 here, number 2 here in position 2, 2. That, as we did yesterday, I can convert it easily. R1 replaced by R1 divided by 2, R2 transforms to R2 divided by 2, R3 already has a 1, and fortunately the elements on RHS are all even numbers, so division by 2 still gives a whole number. It is not a must, but I am sorry, here you are lucky to have even numbers, so after division still you have, okay, you get whole numbers. So 3 minus 1 followed by 1, second row minus 15, 6 minus 5, 5 minus 2 and 2. This corresponds to the equation I is A inverse times A. So this is the success of the transformation or row operation procedure. Where did we start? We started in A is equal to I times of A, and we are ending it at I equal A inverse times A. So what do we expect actually? I matrix, yes, it is present. A, yes, it is present. So A inverse has to be this matrix. That is the row 1, 3 minus 1, 1, row 2 having minus 15, 6 minus 5, row 3, 5 minus 2 and 2. How do we verify? Is this correct? We have done all the necessary transformation according to the priority, the order in which you have to do it, order in which you have to do it. I have set like this: concentrate on column 1, concentrate on column 2, then move on to column 3. This is the concept. And in every column, you have to convert 2 elements to zeros. Fortunately, if you have already 1 0 present, you are lucky. Consider yourself lucky. And in column 3, you had the experience of converting 2 elements to zeros simultaneously in one step. All right. Now, before presenting the answer, I wish to suggest and advise the students, please do the checking whether A times A inverse or A inverse times A, does it get you I matrix? This is your task. So let me just write a small verification procedure, which I have already told you. It is not part of the body of the solution you have to present. It is in your interest in order to score the fullest marks allotted for the question. All right. So let us do it. Verification. What is the given matrix? Let me write it here. It is 2, 0, minus 1, second row 5, 1 and 0, and third row 0, 1 and 3. Okay. And the A inverse what I got is 3 minus 1, 1, minus 15, 6 and minus 5. Row 3, 5, minus 2 and 2. What are we going to verify? I want to verify whether first row, first column is a 1, second row, second column product whether it is 1, third row, third column product whether it is 1. And 100% it could be correct. Check first row and first column. So you know 2 3s are 6, 0 into anything 0, minus 1 into 5, yes it is 1. Verified. Now let us move on to second row, second column. What is the product of corresponding terms there? Pairs. 5 multiplies minus 1, minus 5. 1 multiplies 6 plus 6. 0 multiplies minus 2, 0. The answer is 1. So you got 1 from position 2, 2. Correct. Third row, third column. So get the answer. 0 into 1, 0. 1 into minus 5. And 3 into 2, 6. Answer is 1. So all the diagonal ones are already obtained. And what I wish to suggest is check for 1 or 2 zeros also to ensure you have done 100% error-free operation. Let us check first row, third column. First row, third column is a 0. Let us do the first row, third column. Are we ready? First row, 2, 0 and minus 1. Third column, 1, minus 5 and 2. So the pairs will be 2 into 1, 0 into negative 5, 1 minus 1 into 2. So you can see the product pairs are 2 into 1 and 0 and minus 2. So the answer is 0. Yes, first row, third column should be 0. What about third row, first column? 0, 1, 3, 3 minus 15, 5. You can verify. 0 into 3, 0. And 1 into minus 15, negative 15. 3 into 5, positive 15 gets a 0. So 100% you are verified and you can claim your fullest marks from your teacher. Is that okay? So now let me tell you A inverse confidently. You can present the answer 3, negative 1, 1 minus 15, 6 minus 5, 5 negative 2, 2. Okay. Thank you, students. I hope this was a useful session for you. We learned the method of performing row operations to a 3 by 3 matrix, and whatever be the matrix given to you, always obtain the result in the third step. Your conversion to 0 closes in the third step always. Okay. And the last one modification which may be required is conversion of the diagonal elements to 1. And of course, you need to spend time on verification of the result. Thank you. I'll meet you in another session. Okay. Take care. Bye.